Okay, well, this number will work either going straight in, which you normally do with your cross slide, or with the compound slide at 29 degrees. Typically when you cut a thread, you set your compound to 29 degrees. You have your tool, and you start here and you move in and cut only with this edge. And say your spring cut or the last cut, you'll go in maybe 1,000 on your cross slide, which is this way, and you'll cut on both sides just a little spring cut to take away the theoretical edges that you'll have here from doing that. I know there's some diehards that say it doesn't work. The compound is all this different trigonometry you gotta do. Well, it isn't. Go by this formula, minus 5 thousandths from that 66 dimension, and I guarantee you'll be within 3 or 4 thousandths of your finished thread. Now that you have a way to calculate how deep you gotta go, well, how do you check a thread? We all do have a nut and you thread it on, which works. If you have a mating piece that's small enough that you can hold it in your hand and thread it on the lathe, that works too. That's always a really good way to do it. Now the home machinist or home hobbyist is probably not going to have the funds to buy plug gauges and ring gauges for every thread there is. So another easy, simple way to do it is to get one of these. This is only about 20 bucks. It's called a thread measuring wire set. Basically, you're measuring the pitch diameter of your thread, and pitch diameter is a theoretical cylinder through your threads. So it's basically the middle of the major diameter and the minor diameter. When you use the wires, this is another thing you won't be able to see on this, but basically you have 3 wires. There'll be 2 wires in 2 threads and 1 wire in 1 thread, and you measure over the wires with micrometers, and it'll give you a calculated pitch diameter. When you buy this set, you can see inside there's a bunch of rods in here. They're accurately ground, centerless ground rods, and they each have a dimension, of course. When you get the set, you get this little chart, which you can't see on the video, but it'll have how to calculate with what wire to get your pitch diameter. You can basically do any pitch on any diameter and use these wires to check it. They are kind of hard to use because you have 3 separate wires, and you gotta kind of hold them and then put your micrometer over everything. They do sell thread wires that are 1 wire looped around, and there'll be little tangs on them. You squeeze the tangs, you put it over your thread, let it go, and it'll collapse onto your bolt or whatever your piece is you're measuring, and it'll hold itself. You can just run a micrometer over it, which are actually really good for all the standard sizes, but they're limited to only the standard size. The separate 3 wires, you can make any kind of thread you want. You can make a 7 3/4 by 8 thread and measure it with this. To buy a ring gauge that big would be outrageous amount of money, and they just don't make the other type with the wings I was talking about to measure that. Now measuring pitch diameter with the wires will theoretically give you the right dimension, but if your tool isn't ground correctly, it's not at 60 degrees, or it chips, it's not going to tell you if you got a bad triangle. Typically you can overcut the thread and you'll get a nut to spin on, or whatever you gotta have spin on, no matter what the form is. Basically, the only way to check you have a perfect triangle form is with an optical comparator. And honestly, out in the field, you don't have a perfect triangle. You're supposed to have a little tiny flat or a round in here. You put a little flat in your tool. There's really no set dimension for that flat. They basically want the flat there because it makes the thread stronger. I guess when it comes to a straight, sharp corner like this, like it shows in the book, it makes the thread weaker. Well, without rambling too long here, that's the formula. Pitch times 0.866, or cosine of 30 degrees. And all pitch is the amount, or 1 inch divided by the number of threads. That's what pitch is. That's what 0.076 is, basically the length between the two peaks. That's what 0.076 is on a 13 pitch. Well, I hope this helps some people. Obviously, you can, whatever you do to make a thread, you can keep doing it. If anybody wants to see the thread being cut and using the formula, you know, write a comment. I'll make a thread on the lathe. We'll do the calculation and we'll cut it and see if the numbers will come out and see if it actually works. But I figured I wouldn't do that because there's so many videos that show thread cutting on the lathe itself. A lot of good videos too. As you can see, this camera doesn't really pick anything up unless you're far away from it and it's really big. But that's it for today. I got a couple other little cheat sheets or cheat formulas for stuff like bolt circles, feeds and speeds, keyways, what major diameter to turn for a square and hex. I'm sure everyone's run into that before. If you want to cut a hex into something, what diameter do you make it? Well, there's some pretty easy, simple formulas for it. Well, that's it for today. This is the formula. You should be able to read this in full screen on YouTube. I'm sure it'll come out. Like I said, I got some other cheat formulas that are they're not my own. I didn't come up with any of these formulas. They're just stuff I've acquired over the years of being in the trade. Just leave a comment if you want to hear them. I'll put them up. If not, I'm not gonna do it. Well, that's it for today.